This is how it works. So what is problem here? To provide object on conveyor belt, right? Provide object on conveyor belt in time. Now to solve problem in this all system, what steps are required? So first of all, we need to define proper specifications, then scrutinize the problem, segregate different stages, what is knowledge required for each stage, and we need to choose best solving technique. Now in this particular window, or in this particular example, what we want is that we need to find path for that particular part, right, to destinations, correct? So we need to find this path, right? This is what exactly our problem, because there is a timing. So we need to keep that object on conveyor in time for that particular operation, maybe drilling, cutting, or whatever it is. So now how it is done? So first of all, let us define certain terms. First of all, set of goals. That means what should be done. So bot has picked up object. Now step by step it has to go there. Then set of objects and set of operations. So overall problem means what? What are goals? What are objects? And on these objects, what operations are to be performed? Then goal is desirable state, right? And any action is called as operation. The action is taking on object. After this, set of goals are nothing but finding route and placing a object on conveyor in time. Then what are objects here? Various spots, the conveyor belt, and the robot. Because we are assuming that object is already picked up and now it is to be placed. So what are operations? Now picking, carrying this object over route, and finally placing it. Now problem space is abstract place where all valid states of operations are there. In this problem space, there can be one or many solutions. In our problem, there can be one path or many paths. Every time, depending on what time object is picked up, the path can change. Many times it has to skip the steps and reach in time at conveyor within the problem space. Now here, this overall space involved in 3D is called as problem space or configuration space. Then these are various points where we can have path can be going. This can be marked by sensors. This can be found by camera, right? So there are various aspects of system. How do you define the system or design the system? So we say generally these are nodes. And from these nodes, we are finding a suitable path. Now there will be one path in at that particular moment that can be optimal. If you are having ample time, bot can take relaxation and it can move from long route also. If you are having very short time, bot will move in a very faster way. Because if bot reaches early, still bot has to wait. That will be a problem. And if you are reaching late, then object will be passed. See, this is why this is intelligent problem. If bot is waiting here, then bot has to wait till application has been complete. Till that time, this queue will be increased. So intelligence in this problem is there. This queue should be maintained and this queue should be maintained, and both should be one as one. In this case, now bot has to sometime make time pass, and sometimes robot has cut the time steps also so that it can reach early. So every time estimation is required, provided that object arrival, all this data is with robot. That here both queues are updated to robot. That's why it is intelligent applications. In normal cases, bot will have only one path. It will be taking object, going there, wait, or put fast. This is normal bot, program bot. Intelligent bot will be managing on time. Everything will be managed on time. If delay is there, it will go fast. If time is there, it will relax the speed. Now state space means where all the program states, search states are there, right? That will called as state space. That generally all the nodes represents a state. So all the nodes consist state space. See that this is what state space, where all nodes are exiting, and within this state space solution is found. Outside this is program space, where robot, the conveyor, everything is involved. State space, that is, this is problem finding space. This is what search space. These all things are fixed, like wall, bot is fixed, conveyor place is fixed, right? These distances are fixed. So this is problem space. What is varying is inside this state space, various states are occurring, they are varying. Okay, this is one more example for state space called as 8 puzzle problem. In this 8 puzzle problem, generally we have to organize 1 to 8 numbers serially. 1 2 3 4 5 6 7 8. So any initial condition will be given, that is what said as initial state, and then with minimum efforts we have to arrange the final state. Final state is also called as desirable state or goal state, right? So from initial state to final state we have to go. See there, this is what initial state where bot was there. This is current state, bot is at this position, and this is what goal state where bot is going. In 8 puzzle part, like this is software program which organize these digits from initial state, that is they are random right now, to goal state. Goal state is 1 2 3 4 5 6 7 8 in sequence. So now it start dissolving. So from initial state it has to go to this final goal state. So it has to rearrange applications. In 8 puzzle, it is allowed that at a time only one movement is possible. There are certain games in childhood we also played about this. Okay, so now initial state is a start point. Final state is goal point or goal state. Now state change. This is automatic operation. So we need a successor function. That means from initial state, next state it has to go. This mathematical function is called as successor function. For example, right now T0 is the state, then T0 plus 1 will be next state, and bot has to go automatically to the next state. Okay, this is what state space. State space can be represented by various forms, like it can be map, it can be a tree or arrangement of nodes, it can be a graph. So various techniques are there to represent the state space. Similarly, we can program this directly with various nodes or various types of map destinations. Now two structures are very popular. One is called as tree and other is called as graph. First of all, look this. This is what graph. Now remember that diagram. This is what state space. These are nodes. So graph represents a path from node. Here also there is a path from node to node, or how it is traveling to the destination. This journey is explained by graph. And then in tree it goes step by step. Or see now, graph is non-hierarchical. That means it represents everything at a time. Tree is hierarchical. That means tree explains first go to point A, then go to B, then go to D, or take this path, then it is divided. So every time decision can be taken. On the contrary, graph is set of nodes and edges. This is graphical or geometrical most probably. On the contrary, tree has only one path. Graph can have many paths. In a tree, if I look at tree diagram, at a time there will be only one path to go to this D. So if I have to go to last D, if you can look pointer A, C, B, D, there will be no second path in tree. On the contrary, if I have to go to D in this graph, then I can have various ways A, B, D, A, C, D, A, C, B, D. See, graph gives you several ways to reach destination. Tree gives only one path. Now, problem definition within a state phase. So there are actions, initial state and the goal state. Okay, I'll skip all this part and we'll come to the search process. So search is problem solving process. So now search is now a particular structure, maybe in software or maybe in hardware also. In both cases, it is a structure. So first of all, it is a repetitive process, that is loop, until I am not reaching to the destination. So list of nodes is required. So that is called as fringe, that is L, right? So list of node is there, that is called as L. So we have to select node from list and check that whether this is goal node. If yes, stop search. If not, then this node should be removed and next node should be selected. Here we need successor function, because how your nodes will be generated. So there will be mathematical functions, there will be various logics, and they are actually algorithms. How to move from one node to other node. First of all, basic search algorithm requires this loop, then list of all the nodes called as fringe later on, and then it's a process of selection. So take first node and check that this is goal or not. If not, then take next node, again check it, and this process should be repeated till all nodes and final your destination node or goal node is coming on. Again, where is a variation now? How you are arranging this list, how you are selecting next node, then how you are generating the nodes. So these are various things that will be classifying different types of search algorithms. So how list is there? So list is from left side or right side, or list is random. Then how you are going to next node? What is logic for that? That also defines search algorithm. How you generate the nodes? That is also search algorithm. So based on these techniques, various search algorithms will be there. See, now this is one example is shown over here. So we start with 0, whether this is our destination, right? Our search required is 47. So 0 is not, 4 is not, 7 is not, 10 is not, and when it is coming to the 47, at that time our 47 is a goal and we stop there for a part. Now informed search and uninformed search. In case of our problem, if I know all these states or if I know all these nodes, then I am having information. I sent robot in very first operation and find out all the information about this space. Then I am having information of the environment. I am having information how much is the distance, right? So this is what called as informed search. In case of uninformed search, I do not have any such information. So I have to just experiment and learn, and I have to manage, because I don't have any sensors, nodes, or predefined information. So first I will try this and then learn, remember that, try second, try third, and I start optimizing. But in this case, environment needs to be studied. So this is uninformed search. In this case, all information is present. Grid is there or certain paths are defined. So I can find very easily. Now some terms regarding search algorithms. Completeness. That means if there is a guarantee of the solution, whether a particular algorithm, whatever we are learning, is giving guarantee or there is a specific solution exists or it gives, then such algorithm is called as complete algorithm. So guarantee of solution is the first property. Second thing is optimality. That means whatever solution found out must have minimum cost. That is what called as optimal solution. And third part is time complexity. How much time is taken? So number of nodes expanded and how much time required to find out your solution. And finally, space complexity. That means how much nodes can be resolved, size of the list, right? So four parameters are there: guarantee of solution, whether it is converging or not converging, what will be cost for the solution, time for solution, and how many nodes are there in the list or how many nodes you can take at a time. This is what called as all these four properties are applied to the search algorithms. Now these are all types of search algorithm. Blind search, that is uninformed search, is classified in four parts, that is depth first search, breadth first search, then iterative deepening and iterative broadening. Of course, we are discussing only first two, depth first and breadth first. Informed search, in this case we are going for heuristic search, further it will be classified again, and best first search. Then there will be constraint satisfaction search, and last is adversary search. We are learning depth first search, breadth first search, then informed search, heuristic, that is A star algorithm, then best first search. Again, best first search and breadth first search should not be confused. They are different parts.